Hello, hello. Adrian, you
Hello,
ready?
everyone. Hello, Dennis.
Loosely coupled architectures on today's agenda. This is quite an interesting one. We got quite a bit of mixed feedback on the topic. Adrian, you ran a survey. What do you think about the topic? Excited?
So we ran 4 polls actually over the weekend, and I think Friday and Monday. And the interesting part was that this is definitely a senior topic. So it's not about only for seniors, but only seniors responded mostly.
Mm-hmm.
And that was quite interesting because on the last 2 topics we had together, it was a very mixed thing. So people wanted to know of all stages. Of course, the majority feedback this was always the seniority, but in this case very particularly. So, and I think it's because of, let's say, loose coupling is a quite high level thing. It is very connected with the outcome. It's very connected with the productivity idea and all this kind of stuff. And of course, it goes down into the operational part. But
Mm-hmm.
to actually introduce that, and the idea behind that is settled quite high in the topology. And yes, this is what I think about that. So this is what I saw regarding this topic. Yeah,
And you said topology. Do you mean like the vertical or the
the
experience
vertical.
level?
Yeah, the
The
vertical.
vertical. Okay.
Yeah, yeah.
Okay. So as in it being quite a high audience. So architects, senior architects, TPMs, managers,
Hmm.
integrators. Okay.
Everyone actually working on the long-term vision, but and this is what I wrote as well in the summary of that one, is that I think it should be more interesting for more people. So actually,
Yeah.
more people should engage with that topic because, as I said, it is as well an operational and technical aspect to it. And yeah, there we maybe should bridge a little bit the gaps today as well, and helping
Yeah.
with using an easy language to actually explain it to a broader audience. Why should you be interested in loose coupling? It's not only about using microservices or something like that. So it's a huge variety. And what I wanted to add as well is loose coupling is, we need to define a little bit of context today because it
Mm-hmm.
is huge. For example, so all our polls were about web applications. So we thought that initially, but not most people, but many people actually responded with the idea of, for example, how do you use that on embedded? How do you use that on some kind of, even in the idea of monolithic systems where you have the decoupled, or let's
Mm-hmm.
say the decentralized variants and stuff like this. And this is an interesting aspect. So we should stay in some kind of context today
Mm-hmm.
to make it easier. And I think modern web applications are actually a good context because it's understandable by anyone.
I think that's a good guideline to follow. So just to say hello to everybody in chat. Hey chat, if you can hear us well, let us know if you're here. If you have any questions, happy to start off with questions. Angel, Victor, Vitor, it's great to see you. Glad you could all make it. Had a few last minute joiners as well. Very excited, Thomas. Yes, we are streaming on YouTube on @Technologies Podcast. Um, always do double live streams just in case because it's handy to have the backup, and YouTube is a little bit more platform friendly. So our agenda for today is talking about the sort of ironically the benefits to juniors and tech leads, right? So we're sort of trying to really not focus on like the expert audience of senior architects who are doing this by default, but we're focusing on building up courage for juniors to try it more often, because we don't see a obvious net negative on this, other than perhaps it being a learning curve. So there's that aspect. The other aspect is it's great to know for leaders and architects, especially if you're non-technical, if you're like an engineering manager, but you're not really an engineer, or if you're a project manager, um, to understand why this is important and how it manifests and what the problems are. Generally, the business outcomes that show as a lack of, as a consequence of not having loose coupling is some kind of slowdown, some kind of a huge blast radius on like some changes. Developers tell you, yeah, that's easy. That takes a day. That other thing that looks similar, that takes 2 years. And then everybody's scratching their heads like, oh, what do you mean? This looks almost the same. Why is this so different? And usually it's touching on something that's tightly coupled to something very important that nobody dares to touch. So the agenda for today is just helping you build vocabulary and confidence to apply this more often, then understanding why you should be doing it and how it affects your sort of technical depth / productivity. The obvious culprit here being some kind of big ball of mud or monolith. And number 3, if we get time for it, to talk about the downstream consequences of using microservices. Microservices usually come up when somebody says loose coupling. Is that what they mean? Is that enough? Are we missing the point? So that's our topics for today. And I'm sure there'll be some questions and we'll be jumping back and forth. Let's start with the first one. So I phrased it as risk and stagnation caused by tight coupling. So those of you who are here in chat, how is it that tight coupling manifests badly or negatively in your code base? To the degree that you can tell. Some kind of monolith problem, big ball of mud problem. Let's talk about that. And while we wait for the answers to trickle in, because we do have a little bit of delay, Adrian, what is a horror story from your experience? You work with small, medium businesses. You like cloud native. That's sort of your middle name. How do cloud native and small and medium business and tight coupling go together?
Let's say I don't need to talk about, let's say, other companies. I stay just with my own experience in this case. And for the majority of time, we worked with monoliths and quite old stuff like IIS web service, Apache web service, a mixture of PHP, C# and all this kind of stuff. And actually it was, as you said, a big ball of mud. So that was basically all punched into one web server, which was capable of running several languages next to each other. It was horrible, coupled with several databases. And, the horrible part of that was this big, this ongoing stagnation. So it's actually something where you cannot move anymore as a company. So you wait for features for ages, and this puts stress upon the development, stress upon the business, stress upon everyone. And the only way you get out of this, is by slicing it up, and try to get every slice somewhere else and try to run it in some form of isolation. So this was the basic idea several years ago, to just say, okay, instead of building new stuff upon that, to actually get something running, we need to migrate that to something different. And then was the point where we basically work towards a solution. And then, as you said, which is my middle name, is Cloud Native. That was just a way for us to migrate slowly but steady into containers back then. And we hosted the containers basically in the cloud native way. And step by step, we got out of this mess, and it's still ongoing actually. So it's nothing you do in just some weeks or months. Because if you build, let's say, 10, 15 years of software, you just don't migrate that in 1 year. It's basically not realistic. But this was our horror story. So basically it endangered the entire business. So this is what I would call it. And if we wouldn't have made it, let's say, or started it several years ago, I think it was 5 years ago already, then we would probably be already, out of business with actually that kind of business branch we still have. And yes, this is what I can tell about that. And cloud native was not the solution. Cloud native was the target, where we wanted to go with. But the idea was to basically decouple everything. So when we, speaking about going from tight coupling to loose coupling, you need to decouple. So actually, this is the action you need to do. And this was done by a Strangler Fig migration pattern.
One of my favorites as well.
Yeah, it's working very well. But
ironically, a lot of people don't know about it.
Yeah.
So, but that's why you have coaches. And
It's
people like
basically
us.
you do it step by step,
Mhm.
one piece after another, but you let it run both at the same time. And on
Mhm.
some point, your old legacy system basically disappears, and
Yeah.
it's going in one motion, so there is no stop and stuff like this. It's quite interesting. It's complicated but interesting. But once you're inside,
Yeah.
you don't want to go back anymore because you are in motion again. And still, of course, you have your old stuff, but
Mhm.
it doesn't matter that in that moment that you have old stuff because you are in the delivery process again.
Yeah.
And of course, when we go into a newer application or greenfield projects now, we only do loose coupling. There's nothing else which comes actually to our mind.
Mhm. So we have a few responses in chat. I just want to highlight those because they do touch on exactly this topic. I'm glad we have a lot of enthusiasts in chat. So not experts on this, but we want to go there, but we always figured it's complicated. So we have a comment from John, who I just met and invited to come network with us. So feel free to connect and chat, by the way, talk to each other, connect with each other on LinkedIn. This is ironically one of the most overwhelming points of feedback that we get to the stream is a lot of people just come to chill and vibe and then connect. It's like we're having a little mini conference. So
It is one. Yeah.
that's very welcome. That is sort of the vibe we're going for. That is sort of the setting, the stage, the set we're going for. So that's definitely welcome. So we have quite a few big comments tonight in chat. I just want to address it. While I'm reading this out, Adrian, I did notice there's a little bit of stutter. I'm not sure if there's delay, but there's definitely a little bit of stutter every now and then on your camera. Maybe it's me. If you think that it's a problem, if a refresh helps, then just letting you know that I noticed.
I haven't noticed anything so far.
Yeah, just chat. If you think it's a problem, let us know.
Let us know who's the problem, he or me.
Let us know if it's a problem. If it's not a
Yeah.
problem, I don't want to mess. If it's not broken, let's not delay the stream unnecessarily. So John says, despite the fact I'm not an engineer, I've created content on this topic together with senior devs in my company, so looking forward to broadening my understanding of loose coupling in architectures, especially gaining more insight into potential business outcomes. I mean, for me, the potential business outcomes are exactly that. You have a potential of business outcomes, and loose coupling sort of allows you to retain access to that potential. I would say tight coupling, the opposite of loose coupling, would be that the potential of good business outcomes actually goes further away or just becomes zero. Because you might say there's all this opportunity, but the tight coupling sets such a high cost to acting on all opportunities that we just self-censor. We just say, yeah, we should do that, but in our system, it's hard to do that, so we'll probably never do that. And it's that self-censorship. It's that almost apathy level of planning of, yeah, like we need to do that, but like we can't touch that part of our system. It's that kind of blasé attitude towards just the mess that's already there that is tight coupling. At least from my experience, I worked in very large companies where this was a problem, where you either created and then maintained or inherited a very large mess that worked, that people paid for, but then AI came along. It's like, hey, can we add this to AI with AI? And everybody's like, no, that's touching too many tightly coupled core systems. We don't want to touch that, because the original authors are no longer in the company and nobody knows how this works anymore. So the blast radius of making a mistake is enormous, and then it carries a risk. And then people would rather avoid risk if the outcome is not beyond beyond imagination high. Anything you want to add to this, Adrian?
Yeah, for me, we had the connaissance in the last stream. The buzzword connaissance is actually not a buzzword; it's a metric, and it's very important here as well. So the worse you are in that area and that metric, the more complicated it will become, the more costly it will become to actually do something. This is then the stagnation, actually, and of course it's harder to get out of there as well. So we don't say that it's easy to get out of that, but as soon as you start, then you'll be reducing this connaissance metric. So for example, if you have as you said, you have several systems connected tightly to each other, and you start to have, let's say, something new. You build up in some kind of isolation next to it, and on some point it takes over. Then of course all the couplings, they are gone. There is no line in between those anymore, and this is something we should actually adore to do. This is just what I wanted to add.
Yeah. So this is, for those who don't know, I didn't know this either. Very late into my career. This is a map of connaissance. So these are the various different levels of connaissance. Connaissance is in a way what coupling is between modules and packages, but connaissance also applies to object-oriented structures, and it translates very well to domain-driven design. And it translates very well to microservices and sort of modules and contexts and services in the more sort of behavioral side of design, software design. So what you want to do, loose coupling is considered when you have connaissance of the top end of this chart: name, type, meaning, position, algorithm. That's its loose coupling. Tight coupling is when you have connaissance of identity, connaissance of value, connaissance of timing, connaissance of execution. Connaissance of identity being, I need exactly this reference of object. I can't work on a copy of it. I need exactly this one. That's usually the DORA M problem. That introduces high coupling because you need exactly the original copy. You can't work on the data. You need the original value of it. You can't work on decoupling systems by making them eventually consistent, because you have a request response paradigm. You couple to it. There's nothing in between. So you have coupling of timing. There is a sort of order of things, and that's execution. Execution is the order of executions, and the timing is like, what is the timing between these events? Does it matter? Connaissance of timing is actually a little bit more complex, because it might relate to, am I allowed to execute this command if it's a to-do list? If it's a bill that I have to pay, if it's due for over a year, am I still allowed to pay it? That will be connaissance of timing. Does the behavior change if the timing of it is extreme? This usually happens when one of your cron jobs stops working, and then you don't know what to do. Like, is it safe to turn it back on? Like, is it too old now? Is it still, like, usually we send a message when it's more than 24 hours, but now it's been more than a month. Is that meaningful?
Are you actually allowed to still execute it? So this is the question.
Exactly. That's connaissance of timing. Yeah. So let's just go back to I'm just going to turn this off. Let's just go back to the questions. So Max, I'm here for just broadening perspective. I like loosely coupled architectures, but I'm not in microservices, web SaaS, etc. I do solutions architecture for embedded systems and their associated applications. The issues are the same, but perhaps not so visible. That's a good point. Usually when we say loosely coupled architectures, people say, oh, that sounds like something I need Kubernetes or cloud or Docker or Kafka for. We don't have that. I don't want that. But you can think about loosely coupled architectures, just internally in your project. Adrian mentioned the strangler fig. The strangler fig is essentially you saying, I'm going to treat some legacy system like if it's a read-only system, and I'm not going to touch that code. But I'm going to wrap it. I'm going to, strangle it in a new system, proxy all the calls that I'm not touching, and those calls that I am touching, I'm fixing as they come sort of in transit. Then you sort of strangle it and you replace it. And that system works usually in process. Sometimes it can be orchestrated to work through a proxy, a reverse proxy, a load balancer, a local process proxy solution like PM2, or perhaps you're using something like Swool for PHP, or any kind of internal messaging system that is intra-process in the other ecosystems. Or it can be as simple as just having an application, like a web router, and you're just deciding to, that this path now goes to that server, or goes to both servers sometimes. So if it's the same result, then keep what the old one said. If it's not the same result, then throw an exception because we didn't migrate correctly. Actually, that's how Khan Academy migrated. They went to a loosely coupled architecture. It took them a few years, but that's how they migrated. They said, we're just going to do them side by side, and then we're going to gradually compare, use the live system as a unit test to see if we're actually migrating correctly. That's also a good example of loosely coupled architecture. Dean Swift, a new face on stream. Well, welcome, Dean. We have common models that are reused throughout a C# solution, many projects. So changing those can affect many different projects. Yes, so that's how tight coupling can negatively affect your project. Angel, I've been in situations where in order to write a single working test in a core part of a main product that needed constant change, it would be necessary to work for months just in that. Yes, we know that pain. And the thing is, you probably need to do that once to get the entire team across the pain to just work up the confidence to actually tackle this. Because avoiding this is actually, for the long-term health of the company, worse. Right? Like that, and that's the hard part. That's the management part. It's like, is it hard? Yes. Is it painful? Yes. Okay. We need to make that less painful. Right? That's the hard parts of project management. Adrian, you just made a really serious poker face.
Because this is this continuous enhancement, continuous modernization. It was the term continuous modernization, and every time I came up with that towards business, and confronted business with that term, it is not hesitant, it's reluctant in this case. So as soon as you get to the point where you say, okay, we have a legacy system and we want to get away from this, maybe a legacy code base, legacy solution, no matter what, and you say, okay, we have a pattern. Okay, great. So what does this pattern mean? So we need this and this time to actually go through and maybe even extend the teams, possibly that you need to do that because you have still your daily business. And as soon as you come up with the idea of continuous modernization after this process as well. So because they were used to that in the legacy system, you had this updates every some month and then you can, leave it. And on some point you suddenly want to have weekly or even daily changes to the system. You want to have a new way of working, and to get to that point, you need to restructure your culture. You need to cultivate an entirely new culture, a new way of work, implement trainings, maybe get mentors into the, coaches into the company. That you need to change a lot, and having two systems in the same moment. This is basically the Strangler-Fig pattern. You have the new and the old system, and you need to handle both at the same time. So it's first of all more complicated, and later on suddenly you need to do this ongoing. And this process is continuous modernization, how I call it often, is quite hefty and hard to get actually, let's say, signed off by the business part, because they feel like, oh, we haven't budgeted in for this application, but because actually it's necessary to have that, but it was never budgeted because the old way of working was just this very old idea of, I have built a software and the software is there for several years and I pack it or burn it even on a CD and, ship it to someone via package or something like that. And we need to get rid of this thinking. We are in the age of continuous delivery. And this is where I had my face maybe now. It's because I had a lot of pain because of that in the past to get to the other side, let's say.
Anyana, thanks for joining us again. I remember your great questions from last week. So answering my question about how it manifests, how tight coupling manifests in their code bases, she said, development cannot be broken into smaller chunks of work and work by multiple teams. Yeah, that's the main pain. It's like, whatever I do on this system, it's going to be at least this much, and it's going to be annoying. And then nobody wants to work on it, and then it sort of gets put off, and motivation is low whenever somebody needs to touch that part of the system. When coupled, the development needs to be done one single person team. That means slow to market. Yeah. Can you touch on how to start to see the coupling happening in the design phase? So Anyana asked this question, and I have to say, Thomas, our first YouTube comment. So that's a first. Thank you. This is also about the tactics. So I think that's going to be a natural second part of our conversation. Just want to highlight everybody that commented. Vitor, for good or for bad, to solve the ball of mud, we need to refactor with abstractions, but careful because it can be a shot in the foot. Too many abstractions will be difficult for humans to understand. And of course, before you start refactoring, start with a good test set. But organizations that do not value the developers' efforts to have better software, refactor operations that are needed to solve technical debt and implement good values of coupling and cohesion are difficult and sometimes impossible to sell. So developers need to be able to scope it secretly when delivering when delivering user stories, scout rule on extreme.
Well, there were many points now in many comments, to be honest.
Yeah.
Um,
What stands out to me is the idea of this is an abstraction problem. Careful, don't over extract in a silly way, right? So don't over extract in a way that is not natural to the business. I think that is very important. Design is one of the hardest problems in software. Understanding coupling, understanding connaissance, and we like to think that once we get to that abstract factory controller provider thing, that's actually what we want, but that's not what we want. That is a symptom of us no longer having names for our abstractions, and that's what you want to avoid. You want to avoid abstracting to the point where you're using the pattern and the keywords of what the class or the object is inside the name of the thing, where it's like an abstract controller thing. A controller already doesn't mean anything. A manager of something doesn't mean anything.
But I see already the problem. So
yes,
you cannot start this by viewing the tactical operational side. So this is wrong already.
Okay. Let's talk about that.
So when you want to start this, so I have I think my fourth Strangler Fig now behind me, successfully actually. And every time we started, so not the first time, but the second time was to start with the low-hanging fruits in the business.
Snacks, distractions, so annoying.
So for example, in this example, it was a large franchise system, B2B system, which was there for marketing, or is there for marketing still, and that was actually this big ball of mud. And so we decided, first of all, what could we do in order to fix the most severe problems we had, and that was security and performance. So actually those system performance, and the big bottleneck was that, especially in older monolithic systems like PHP or C#, you have this tightly coupled front and back end. They're actually one thing, And
classic PHP C#
exactly. So this is how we grew up. No, we want to go into a modern way of working. So we decided, okay, we need to go with a decoupled front end first. So, and that was actually the first step. So we've implemented an Nginx in between. So this Nginx is basically the federator. So it's a server which federates the application. So it's the new API gateway, let's say. And then you basically step by step removing pages from the old system and move it towards or exchange it with the pages built in a new application, which is basically an SPA, or can be an SPA, or and
so SPA being single page application. That acronym.
A single page application, but it can be a static web. It can be actually anything, just something new, which is not connected deeply, tightly with the old application. And that was already a low-hanging fruit, and we solved both of the problems because we had a new single point of entry, and we could basically mitigate all the so there were in the old system, there were not only front end, there were the APIs for the front end as well. So basically, those are most, the SQL injection stuff and all this kind of thing. That was basically gone because we basically blocked out the old API, and we implemented a newer API via microservices already, which supports with the backend for front-end architecture, the new front-end, and that was federated again by the Nginx server, and we basically removed the security issues. We tested that with white hacking agencies, and we had no performance issues anymore because basically the new application was fast, and we could support it, for example, with caching solutions. So even if the old application is slow in regards of, let's say, database performance and data aggregation, but together with caching, you can mitigate this as well. So this is what I called low-hanging fruits, because if we would have started with the backend, we actually could not even really migrate. You need to start with what makes business sense first, and this is get these pain points off. And the last point I want to say tell about this is in a business perspective for the user, it was already a new and fresh system, even if the majority of the system wasn't yet migrated. And this is what I mean by that. And this is where we should start and think of how we want to actually organize that.
So you touched on a few things there. So first of all, let me comment that that's already an let's say expert advanced level of strangler fig implementation. Right? So strangler fig is one of the tactics how you pull apart a big ball of mud. It's one that I recommend as well. Especially with being let's say a coach on the team. I'm not taking it away from the team, but I'm encouraging the team to tackle the problem without actually paying remediation costs. So a few streams ago, I did a solo stream on refactoring, and there we highlighted the difference between remediation costs and technical debt. So remediation cost is, now that you have all the knowledge, how much would it cost to just rewrite everything? And that is the cheaper option. Technical debt, and people think that's technical debt. That's not technical debt. That is just the remediation cost of getting a heart transplant. I don't like my heart, I just want a new one. I don't like my system, I just want a new one. I want it to do the same thing, I just want it to be new. The problem is that you have to stop feature development to pay off that cost. That is already enormous, but in relative size, that is much smaller compared to technical debt. Because technical debt is something else. Technical debt is when you have an ideal system of what could be possible, what opportunities could we act upon, and on what percentage of those did we just self-censor because we said, not in our system, not in our team, not at this company. Yeah, like on Facebook and Google, yeah, sure, but not in our company. That is technical debt. When you censor decisions just out of fear, just out of frustration that you do not want to touch that painful thing. As Kaloyan mentioned, hit it where it hurts. Now, and I would like to mention this, Adrian, you touched on this idea of low-hanging fruit, but you're very good at gauging what is the low-hanging fruit that is worth pursuing and what is a snack. I always say no snacks, right? So low-hanging fruit is very easy to do, high value. That's a low-hanging fruit. That's very good. But what you don't want to do, absolutely not, when you're doing strangler fig or any kind of loose coupling inside a large system, do not do anything that is low effort and low value. Don't go about refactoring your classes and splitting them apart and just doing like little small refactorings. Because on a tactical side, yes, for a feature, sure. But on, loose coupling, on what we're talking today, is about loosely coupled architectures, not just loosely coupled code, but loosely coupled architectures, which means that the code, the incision, in order to be loosely coupled in this term to affect the business, the decisions need to be architectural. What does it mean to be architectural? Architectural means that it in somehow affects how you make decisions about what technologies to implement, what features to implement. That's architectural. When there's a difference between are we building this the right way, architectural incisions into the system make it easier to build it the right way. And sometimes this manifests as frameworks, and people hate building like in-house frameworks and libraries. But sometimes it's a bit different. Sometimes you see that your system is just not serving the company anymore, and you need a slight refactor on the architecture to say, no, this is where we were 5 years ago. Now we need to make a slight shift to couple things differently. We still need coupling. Who said that in chat? Victor, right? So sometimes coupling is demonized as a concept, but coupling is inherent to software and a necessary part of it. Agreed. There is good and bad design, though, and there's properly designed tight coupling as well. Properly designed tight coupling, yes. I'm happily tightly coupled to my lungs. Yeah, it's a very good example. I'm very happily tightly coupled to my lungs. And that's called cohesion. Like, I need my lungs. Bad coupling would be, I need Adrian's lungs. Right? I need Adrian to be...
When my lungs would be connected with my stomach, I would have a problem.
That as well. Yeah, that as well. And there are some organs that do work like that. And even our bodies have a tight coupling problem. But it is probably the least of the bad solutions, because sometimes you don't have a good solution, so you just pick the least bad one. And tight coupling can often manifest as, I would prefer not to be tightly coupled to my network or to my database, but sometimes I just need to bite that bullet. And that's sort of the difference between platform as a service and just having containerized or managed containers or unmanaged containers, or just doing everything like directly on the metal. There are costs to that. So there is definitely pieces of coupling that you want for performance, or pieces of coupling that you want for security, or pieces of coupling that you want for being able to parallelize a team or to decouple it from like a different kind of ecosystem, like having a C# team and a Ruby team, or coupling of that nature. But these are architectural coupling concerns, right? So we're not specifically talking about function to function coupling. We are more on the sort of service to service coupling. But Adrian, you did mention an important detail for our C# and PHP community, that in those ecosystems, it is very normal to couple backend and frontend. And that is one of the worst couplings, because that is coupling of identity and coupling of, again, to reference connaissance, that is coupling of value and connaissance of value and connaissance of identity, right? Like I need exactly this backend to talk to exactly this front end, and the value of the objects that are passing through them have to be known semantically to each on the sort of compiler level. And that is the worst kind of coupling, because then you say, well, I want the front end to stay the same, but I want to upgrade from PHP 7 to PHP 8. Well, that's not going to happen because these two systems are tightly coupled together. Okay, can I do a redesign without upgrading my system? Well, no, because we need to upgrade React, and we can't because our build package is tightly coupled to our Symfony and the Composer and the PHP. And
there was this this big thing several years ago where WordPress was releasing its headless API, so that this actually was the answer to this new approach of having a backend for frontend architecture instead of having everything coupled together to a monolith. And as I remember, most actually in the time when I was still involved in PHP, most were not going this direction because PHP world was still very monolithic. I think it's still today like this. Correct me if I'm wrong. So in the audience, if someone says I'm talking nonsense right now, please tell me. So I want to know actually. But this is how I know it from the past. And but this was the big story where, because WordPress is still, as far as I know, the majority of the websites in the internet running on PHP on WordPress, and so it's still basically a topic. So on which point will we see that websites will actually be entirely decoupled from the backend, and not the backend is not seen as a part of the website anymore.
We see this happening now with a lot of headless installations. So this whole modern framework movement that we saw with Nuxt, with Vercel is a very good example of this, where they sort of try to decouple you from the backend by putting you on either a dynamic backend, so it is on an edge cluster, so it is a bunch of serverless functions, or they are hosting you from the same code base, but the code base doesn't have a clear distinction between backend and frontend. So to you, it all just looks like frontend code. And the T3 stack, if you know TO, Primogen, the HTMX and Go community, they are sort of gravitating towards different solutions on the spectrum of, it's all just backend code and it lives with us, or it's all just front-end code and some of it is on the server. That's the sort of, is it server-side rendering? Is it server-side enhancement with hydration? Is it sending pure HTML and then it's being decorated with JavaScript? So there are many different solutions to this, but they are all different niches and nuances of solutions to a coupling problem. How tightly should my backend and front-end systems be coupled? This is ironically a lot simpler in mobile development because you're forced to be decoupled, which is ironic because you would think that the most hardware sort of embedded system would have the worst coupling problems, but actually everybody, most shops that I know, they use web technologies to code for phones, which is a completely unexpected twist that happened like 10 years ago.
Yeah.
Right? So that's things like Flutter, things like React Native are dominating the market for mobile development compared to their native subsystems and frameworks that are only being used for high performance or low latency solutions. So we have a few comments on this. Great participation in chat, by the way. If there's a legacy system that everyone hates and the plan is to deal with it in X amount of time in one go, I think one go here requires emphasis. That future will probably never happen. Leave if you can, unless you have the means and authority to change that culture and empower the team to embrace continuous improvement. Exactly. So this one go thing, in my opinion, is just a cop out. Let's not do it now. I do not want to have this conversation. Because the right thing would do is, this is painful. It needs to be addressed ASAP. Adrian, what's your opinion?
The problem with having, doing it in one go is that it's not done in let's say a average business to business or business to consumer application is large. So it was built in months or even years. So you will need about the same time of pure building time to rebuild it into something new. It could even be longer than the initial one. So when you do this,
that's remediation. That's remediation. That's rewriting the system.
Yes, right. So basically, exactly. And the problem is you don't create value in that time with the new parts already. So if you want to go with the idea of continuous improvement, then go with the idea of continuous delivery as well, because this is your target destination. So do it as soon as possible, because you want to, migrate into that anyway. So otherwise it would be like I go now 18 months, for example, just develop a new solution next to the other one in secret, and suddenly I become a continuous delivery company. And no, it doesn't work. So it is very hard to do that, basically culturally, and the business aspect is very bad as well. So you don't leverage what you've created every month, already. Exactly. And this is just missing revenue, and maybe you don't make it. So and not every company does have the luxury.
I felt that in my stomach. Maybe you don't make it. Yeah, like the amount of times that happens, sometimes it kills companies.
Yes, still a majority of companies on this planet are small to medium-sized companies, and they have very limited amount of resources. So you need to handle those with care. And the aspect of the practice of continuous delivery is just the best one, and it goes hand in hand with a migration. So you should not do it anyway else. I could not recommend it. So maybe there are others in the audience are thinking differently. Then would be interesting for me to know if there are other ways, and I may be missing something. But in my years, I haven't seen any other way which was actually working as good as continuous delivery.
And continuous delivery and trial fig for the legacy systems. Because that touches on really our main point today is coupled systems. Tightly coupled, unnecessarily tightly coupled systems, architecturally tightly coupled systems lead to a bleeding of productivity. And the worst thing you can do is you say, our productivity is now almost zero. Let's make it zero for an unknown amount of time and let's rewrite everything. That is the worst, because that's already almost at rock bottom. And then you say, now let's invest even more. And that is the worst, because all of these in business terms, if you're a business owner, if you're an entrepreneur, if you're a solopreneur listening to this, all of these refactorings follow a J curve. Now, if you're a business owner, you know what J curve means because you see it on your balance sheet whenever you're investing into something new. A J curve is when you do something and it goes a little bit, there's a small dip, it gets worse before it gets better, and then it goes, and then it goes up, right? And you see this in the market, you see this in the stock market. New numbers about inflation, things go down, uncertainty rises, and then everybody gets used to it, and then the markets go back up because there's a lot of money to be made in a recession. There's a lot of productivity to be gained in a tightly coupled big ball of mud. And we have a few questions of those. So Anyana had a very good nuance that I just picked up on. So, sorry for not noticing this earlier, but you said, can you touch on how to start to see the coupling happening in the design phase? Now, I missed that nuance when I first read it. This is a really good question. Can we see that this will happen before it happens? So prevention.
It is actually the job of the architect if you have one. If you don't have one, it's the job of the, let's say, most senior people in your company in reviews to see this. So
it's actually, small to medium companies, let's assume there isn't one. So let's constrain context.
Okay, but in general, I would say yes, it is possible to some degree. Of course, not everything, but let's say if you don't see it anyway, then you've done something wrong, because it's obvious. When you have done some decoupling already,
Mm-hmm.
via refactoring, via migration, doesn't matter.
Yeah.
Then on some point you start to get used to it, and you can see it coming. You can see
Yeah.
it when you see new changes coming, and you say, oh no, you can't do that way. Oh yeah, okay. And this is what you should then mentor and coach to the, let's say, younger developers in your team, telling them the why. This is the reason why we said in the beginning that juniors and intermediates should have some emphasis on this topic as well, because it's so important. And this is actually what you learn. It's not only architecture, it's programming and design principles as well, coupling and cohesion,
And I would mention, make it specific to your project. And if you have multiple projects, make it specific to each project separately. Imagine your big ball of mud, or your tightly coupled system, or your distributed monolith, whichever problem you have. And we have Max, I think, is working on embedded systems. It can happen there as well. Treat it like a complex instrument, and then learn the patterns of that instrument. It's like, oh, this kind of problem I can always extract this way. With front and back end coupling. Oh, this one I know how to strangle fig. This is one of the most common things that I approach when I'm mentoring and coaching teams on a more tactical architectural side, is that I show them a few patterns of architectural incisions, and they start using that. I show them, Symfony 6.3, 6.4 is now coming out, has the messenger component, and you can use it in a synchronous manner. So you get a event bus, and then at usage, you can decide, do you want a synchronous event bus, so you can do request response, or do you want an asynchronous event bus, and you do eventual consistency. Right, so you can decide, are you doing synchronous CQRS or asynchronous CQRS? Because one of the things that you want to be doing when you're not decoupling, so I think we need to correct ourselves in our terminology, when you're inverting coupling, right? So generally, I have an anecdote on this, and I think, Anjana, thank you. Let me know if you missed any nuance of your question, or if you want to add detail to that. So Thomas, is there a method to get loose decoupling mode when you have a big legacy big ball of mud? What to do in what steps? Do you want to talk about it? Yes, let's talk about it. Adrian, you ready for this?
Is there a method to get loose decoupling mode when you have a
big one, when a big ball of mud? I'm assuming millions of lines.
Yeah, okay. So this is actually what I was talking about. So it was, in our perspective, it was a very big ball of mud. It was actually a mountain of mud.
Mountain of mud. Yeah.
So the first thing you implement always is a federator. So the first thing you need to do is decouple. So you need to actually have something, even before you have the new system or the new environment. In our case, it was the cloud native environment on AWS in the beginning, and later on DigitalOcean. And then you need to have something to federate this. So you need to have a layer. I don't have the diagram for this, actually.
I'm making one. It's okay. I'm making one.
But you have, let's say the top layer, when it comes down from, the internet users coming into this federator layer.
Some kind of router, some kind of reverse proxy, something that can decouple your backend from processing the request specifically on the network layer, right? So in clean architecture, we had a huge month on this stream about clean architecture. People always tell me, how do we start with clean architecture? I always tell them, you don't start with clean architecture. You start lean, you start small, you move fast, you break things, and you want to make sure that you're not really making a mess, but eventually you'll end up with a big ball of mud, and then you clean the big ball of mud. That's how you end up with loosely coupled architecture. But usually you rapidly go towards a big ball of mud, and then when there's market viability, because you do it why? To get cash flow. Once you have that cash flow, then you invest the cash flow to invest into cleaning the big ball of mud and decoupling it. But here is where a lot of teams give up, because they don't know how to introduce this federator. They don't know how to invert dependencies on a backend to backend layer. They don't know how to invert dependencies on a backend to frontend layer. They don't know how to invert dependencies between two databases. They don't know how to invert dependencies between several different flavors of database, like a Redis database and an SQL database, like Mongo. and SQL. They don't know how to run transactions through such a system, right? So the complexity comes from not this being complex because it has a lot of moving parts, but because your team might be dealing with a different kind of complicated. I am choosing complicated, which is a sign of good craftsmanship, over the complicated of working in a painful big ball of mud. Right? So you need to choose your discomfort. Either you want to do it high level, so it becomes hard, like difficult, outside of your comfort zone, but really simple. Like you just need to learn this new thing and then apply this pattern. No problem. Or you say, I'm not going to learn. That's uncomfortable. I get screamed at if I miss the deadline. So I'll just work on the devil I know in my big ball of mud. I know it's painful, but at least I know what kind of flavor of pain it is. And then I don't get yelled at for missing the deadline. And then I don't have to have scoping conversations. Because the biggest part is just not knowing how to sell this to management. It's like, it's a hard decision. Management should be involved. And usually we, point a gun and say, we need to rewrite this. Management says, no. Or what? Rewrite this or else what? I leave. Okay, go leave. And that's not a very good strategy. And that's probably the only strategy a lot of developers know. It's like, I hate working on this software system. I'm going to leave. Bye. And that's already too late, right? So yes, finding it in the design phase is really important. Okay. So number 1, federators. Number 2, invert couplings.
Yes, but first of all, this is already the moment where you need to know in which type of architecture you want to migrate,
So have a goal. Yeah.
Have a goal. So in our case, it was a microservice orchestrated thing, but you can go into other things as well. There's a lot of things you can do. Others prefer decoupled monolith. Others prefer, let's say, a serverless architecture, for example. You can use all of those, but you need to have a clear goal and you need to understand this, because now is the time where you need to shift your culture and you shift your ways of work, and then you start to pick decide which are the low-hanging fruits, which you want to decide migrate first, and then you go step by step. And this is actually the good thing about that. As soon as you have the federator in place, you have your idea of architecture in place, then you can literally go, let's say, piece by piece, front-end piece, back-end piece by piece. In front ends, you definitely will come to the point where you at least temporarily use the micro front-end let's say architecture as well. So because you need to have, at least it was for us the way that we have new front ends and old front ends migrated together in one thing, sometimes even on the same page. You can do that with several ways. This is another topic now, but this you should be aware of all those things, and this is the point where you need to learn to understand before you execute. Don't ever just start right away. Learn what you need to, understand your goal. It's somewhat important. This is
And I touched on this as well in the refactoring talk. Your goal should always be, I am decoupling, I'm dealing with the mess because I have this feature, and now this feature costs X to implement, and if I refactor it, it will cost half of that. Like, having that is very important. Never refactor during downtime. That is the worst thing you can do. Don't refactor because you're not busy. You need to be refactoring when you're busy, on the thing that you're busy with, right? Refactoring and decoupling has to happen on the critical path, on the critical timeline, on the critical project. Now, perhaps not immediately, but there was a great quote. There's a great quote. Somebody mentioned it on my LinkedIn posts this week about you need to do the most annoying thing at the best timing. I'm paraphrasing, but the point is, when you have to refactor something, the moment you've noticed that you have a problem, that might not be the best timing. And I see I have some performance problems. Adrian, can you take over the stream for a few minutes while I figure this out? Okay. I have some delay. Yes, I have some delay. Just let me figure this out.
So just save your point and go on with it later.
Okay. Yeah, I can see the video has a little delay. So my point is, my point is, we want to be able to refactor when we find the problem, but sometimes the moment we find the problem, But when we deploy that thing, then it's good. But we need to really be careful about the refactoring immediately after deployment, because if we don't, then it goes from maybe now, maybe later to never. So it's really important to keep the refactoring and the problem you're working on very close together. Some people refactor before the behavior, the feature. Some people refactor after the feature. But it's really important that you do before or after immediately. Never later. Later means you already missed the window. There is nothing to be gained by doing it during downtime, because the next thing that's coming in will require refactoring somewhere else. And you already want to have dealt with that problem when you get there. It's a never-ending cycle.
At the moment, you are pretty out of sync for me. Are you still with us?
I'm still here. I muted myself.
You are still muted, if you don't know it, or I don't hear you.
Okay.
Vitor does have an interesting point as well. Okay, since Dennis is gone, I will take over here. Vitor, you said that you would say you would go with the modular monolith first. So this is actually an interesting point as well. So you can do that. This is another form. So you would basically, the question is, if you would go with a modular monolith, is that a newer, so is that part of the let's say, the migration process? Or is that your idea to actually do that within your old legacy environment? So I saw that as well. So getting to a new system can be within the old system or outside of the old system. So I prefer outside because it actually feels better and cleaner to do that like this. But it's not the only viable way. So I saw others doing basically exactly that, and on some point everything was renewed. The thing I don't like at this approach is that you have all those still old stuff which never disappears, because but I assume that the modular monolith is a good architecture as well to move into. Yes, but this is a big topic of its own. So if you go for the modular monolith or the microservice architecture or the serverless architecture, big topics on LinkedIn as well. A lot of arguing there, and I think all of them are viable. I personally prefer microservices with containers. This is just we had the best results with that. We were flexible. They were quite easy for juniors, intermediates, and seniors at the same time. But yes, it's actually a viable way as well. Dennis is returning.
I just joined from my phone to be able to contribute, but I do have some technical difficulties, so sorry about that. But I'm here. I'm here with you.
Good. Then we go. So do you want to finish what you have said last, Dennis?
Yes. So the point I was making is that the timing is very important, right? So the problem never really goes away when you're refactoring, and you want to be able to say, I am working on feature X and I'm refactoring because I want to make working on feature X faster or cheaper or more sensible. Maybe feature X made sense when it was alone, but now that we're adding it to this other set of or suite of features, I want to be able to say, I'm going to refactor it to make the architecture more support having multiples of these features, not just feature X, or not just what was there before. So the bit about refactoring during design process and making architectural decisions and decoupling during the design process, it comes with the idea that when you are making this sell to management, or this sell to maybe this more senior staff or the non-technical staff, is that we will make a mess now and clean it up later. Later means that if you don't do it right now, it will remain in a coupled state. So even the refactor will become more expensive later, not just adding this feature, right? So you always have this option of do nothing, just add the feature, and it's expensive. Add the feature and refactor, the expensive will be expensive, and then you refactor cheaply, or you flip around the order. You refactor now, and the feature will be cheaper to add. But if you do it later, then adding the feature will be expensive, and refactoring will be expensive. And for some reason, developers always like to choose this last options because it seems comfortable. It seems like it's the right decision. It optimizes cash flow. It brings the deadline closer to the roadmap, but it's actually a trap. Refactoring later is always expensive, which is why most businesses never do this, because they're not doing decisions from the right perspective. And I do believe my technical problems are coming to an end. So I will just disconnect real quick from my phone, and I'll come back to you on stage. We back? We good? Audio?
P.
Audio good? Can you hear me?
All good. All good. All good.
Thank God.
So actually, we had some interesting comments. So I already commented the modular monolith.
I was here. I heard everything. So
and Vitor was actually following up with small steps. And yes, baby steps sometimes called they are very important. So you need to understand that a migration out of tight coupled architectures is always done in small or baby steps. So it's basically absolutely step by step, and you learn with those steps as well. And you will see that after, let's say, 12 or 18 months of development, your, let's say, newly created components in the last month are way better than they were in the month before. So what you just said is very important, that refactoring, you should do that as early as possible and as ongoing as possible with the critical path you're on. So never waste your resources, but use them when you're actually doing this. So you need to get better. But what I wouldn't do is, I just mentioned that the quality will be, let's say, 18 months later better than 18 months earlier, which is no reason to refactor just for that. So if it works, leave it like this. And as soon as you go to it, start to refactor. Because refactoring is, when you do that continuously, it's not a big deal. So this is sometimes we need to notice that. It will become a big deal if you never do that, But if you have, let's say, good form of reviewing your code, with a team, good communications, good learning, all this kind of stuff, and continuously improving your code by refactoring it during the process, you will never get to this stacked up need to actually refactor. So maybe to wrap this topic up about refactoring.
So Thomas has a good question about testing. And I think he touches upon a really important signal, a pain point. If your system is hard to test because you need to spin it up in its entirety, or there's you can't isolate something and test it, one feature, it's a very strong indicator that you have a coupling problem. And this usually happens because we get architecture wrong, right? So it's not a coupling problem because we implemented it incorrectly. It's a coupling problem because we got the modeling wrong. A lot of people model, a lot of software engineers who are self-taught, or just even well-meaning, well-educated software engineers who come from university, they still, in 2023, model based on a database model. They model their services, they model their APIs based on the database model. The service is CRUD, but not for the aggregates, not for the complex system of the business, but the name of the API endpoint matches the sum table in the database. That's where most problems originate. right? Because when I have a customer and an order, what I care about is a purchase. Now, the purchase has a customer snapshot in point in time because I want to know what is their shipping address when they made the order, not who they are right now. And also the product. I want to know what the price of the product was when they made the order, not what it is right now. Right? So you have this whole family of bitemporality problems of, do I need it normalized and have a perfect source of truth in like a very space storage efficient manner? Or am I actually programming, designing against snapshots in time and everything, delivery, logistics, e-commerce, data companies, analytics, complex analytics, so like streaming services, video processing, any kind of AI related systems, they are working on data in a snapshot of time, not the latest data. I want to know when I made a request, I want my request to be specific to the data that it was in that point in time. That is a coupling problem. Like temporal coupling to the timeline of things is extremely important. And those things don't show up in the database. Those things don't show up in the SQL databases because SQL databases do not have time components generally. You cannot say, make this record go away in 2 hours. It's one of the main features that we use NoSQL databases for. It's like, I want something to self-destruct in 2 hours. I want this record to change in 2 hours. And then you have this complex system where you have a backend system and its cron jobs, and then the front end. And hopefully this sort of gets synchronized to the backend system. That is one of the worst kinds of coupling. That is connaissance of algorithm, that is connaissance of timing, that is connaissance of execution. This sort of long polling problems, refresh, hit F5 because the order wasn't correct, push socket, server sent events. These are all components that you can use to fix your coupling problems, but you got to use these technologies. You got to learn how to use them. And you can get a lot of things done with boring tech. Boring tech being HTTP2, quick HTTP3, maybe sockets, but that's already pushing it. Any kind of abstraction layer that encapsulates server sent push feedback, and message queues. Message queues, it doesn't need to be a complex message queues. Definitely, it doesn't need to be Kafka. It doesn't need to be enterprise grade. It can be end service bus in the Azure ecosystem. It can be the messenger component in the PHP ecosystem. It's one of the best abstracted messengers. Because you can say, I am coding against the messenger, and in my tests, the messenger becomes synchronous. So when I'm writing a unit test, Thomas, you asked, when I'm writing a unit test, I will pretend as if the component is synchronous. So I can just test it a little bit more easily. Now, that that also brings its own caveats. It might have some boundary breaches because maybe it's not supposed to be tested in a synchronous manner. But as a stepping stone, as a learning steps, as I said earlier, treat your big ball of mud like an instrument and test what can you play on it. Okay, this I can strangle. This I can invert the dependency. This I can introduce like a little message queue and just have it in process. Or if I can't do it in process, I can have a simple auto-regenerating message queue on Redis. Redis is powerful enough for that. You don't need RabbitMQ. You don't need new servers. You don't need Kafka. You definitely don't need Kafka. You don't need SQS. You don't need any kind of large enterprise scale application just to create this one little component and decouple it. Make the technology match the size of the component. Start
That's
there.
a very good point.
Learn what the small pieces are. The smallest piece is always a synchronous message queue. In React, that's Redux. It's a synchronous message queue. That's why it's so powerful. And in Angular, there used to be this. It was very popular back in the day, like 5 years ago, was ngStore and the whole reactive programming, RxJS, and we have the whole Rx reactive programming community in C#. You have it in PHP. You have it in JavaScript, TypeScript. You have it in Ruby, Go, Haskell. Right. So there are all these paradigms that give you synchronous in-memory, in-process message queues because they want to practice decoupling on this level, and then make it architectural, and then make it slightly larger, and then they make it enterprise level. A lot of companies don't need to get there. You just want to make decoupling easy. So figure out what is the smallest decoupling strategy for you for your company, for your instrument. What is the smallest decoupling strategy? What can I decouple? Even just not having to go through this giant XML of dependency injector config, maybe I can go through a message queue and not have it decoupled like everything else in the system. Try to get away from the system. Try to get away from the big brownfield mess, and introduce some kind of inversion. That would be like my main go-to, how to do this. Most of the questions are on a tactical level, architectural, or just on the complex side of implementation. What do I do? What is my first step? First step is definitely find a messaging solution that is the equivalent of calling a command. The Linux terminal has figured this out 40 years ago. They have standard in, standard out, and error. So it is a T-junction. And that is their main message queue, which can be synchronous or asynchronous, blocking and non-blocking. And that is their main messaging system that powers the entire Linux ecosystem. That is extremely powerful. And finding that abstraction was extremely difficult.
Maybe I want to really quickly add something before we get away from this comment. Boundaries. So we talked about migration and how to get, being in the decoupling process. People, and it's very important to understand, should not only focus on the technical aspects of, how do I decouple now? Do I use message queues or Kafka or whatever? It is very important to understand that you don't want to get into the same situation in 5 years again. So we haven't mentioned this yet. So you get out of a legacy dead end, and the main idea of this type of migration, of this architecture, is to not become, let's say that the newer application should not become a legacy application anymore. And this is done when you have everything in services, or let's say in modules or whatever, in a modular monolith. The idea is that as soon as this happens, you can exchange or substitute different parts of this application in the idea of continuous improvement, continuous modernization in the future. Which means that once you do this now, you will never again go into this legacy dead end or run into this legacy dead end. And this is we wanted to talk a little bit about the outcomes as well. And this is definitely a business outcome.
I never have to go back to this.
Right, because now let's take an example. We had the system which I was talking about in the beginning was basically based on a shop system and an e-commerce system back then. And we took the idea of that there is a shop where you do purchases and all this kind of stuff. And this is basically a service, a dedicated, isolated service. And it was basically decoupled from the user idea, from the production or output idea of this shop, the production side, the input side, let's say the inspiration side, where you have details or products or something like that. It's completely decoupled from that. So basically the shop became an engine which was basically one big microservice, and this microservice could be substituted to any time with a SaaS product, for example, which is providing that, like Medusa, like Shopify or something like that, and that was the original idea we intended to. So we don't run into because our legacy application wasn't legacy because everything was bad. It was because of some parts were bad, and they were so tightly coupled to everything else that actually everything was bad.
All the good parts were coupled to the bad parts, and then you couldn't iterate on the good parts.
And you need to prevent that in future,
And that is one of the main things. You say prevent it. If you have a signal that this keeps happening, you're not decoupling aggressively enough.
And
if this keeps popping up, you need to go back and decouple it.
And you said that even senior developers or seasoned developers go for database design again and normalization of this kind of stuff. If you had that in your legacy application, you need to have another entirely different architecture in the future. So you need to migrate into a different pattern. You should not migrate from one to the same pattern, just with newer technologies, because you run basically into the hidden monolith again, just with microservices.
Let's become a little bit more architectural. Ricardo, hello. Glad you could make it. Hey, shout out. Vitor, did we address this question?
Yes.
Vitor, this is when I was having connection problems. Okay. So I would say, one of the biggest messes that I see, especially when I'm strangler figging with when I'm applying the strangler fig pattern with the team, one of the biggest messes is when we determine that when you start pulling the application apart, you will notice one of the worst couplings, right? And if I were to share my screen again, right, which coupling is that? It's connaissance of identity, right? Connaissance of identity. Why is connaissance of identity bad? Because it requires you to have the exact instance of the memory of the thing. And one of the worst connaissances of identity, let me zoom in for this. One of the worst types of coupling in a tightly coupled system is being coupled to the database. Now, let me finish. I'm not saying don't use the database, but make sure that one component in your PHP code doesn't talk to another component in PHP code by using the database as a message bus, right? So it's like, I will call this function, but I need to save something in the database first. And then when that is atomic, I will then call that other function. That is the worst kind of coupling. Mm-hmm. So what you want to make sure first is that you're not doing that manually. Because that is step one. When I'm doing stranglerfig, I see developers doing this manually. If there's a problem, I will go to the database and I will fix it by hand. And that is a symptom of not having good enough tooling for the project you're working on. So step one, take away write database access for every single developer. Mm-hmm. All writes to the database should be through one application. And if you're splitting that application, those two applications should be talking to each other, not through the database. That's extremely important, because that talking through the database with each other, that is connaissance of identity, the worst kind of coupling. That's why people say, don't design your database in such a manner that it's implicit that I save something and then I tell you the ID and then you pull it from the database and then you do something. That is the worst kind of coupling. Just send them the data, even if it's in memory in the same system. Just send it, because ORMs usually have this problem. There's the M+1 problem of I will just give me the next item in the list, give me the next item in the list, give me the next item in the list, where like you're looping through and then you're calling a query for every single item individually rather than just using a database, SQL database with SQL for, that's what it was built for, to have cursors. And the other one is the disconnectance of identity, where you say, oh, the object actually lives in the database because the ORM is really powerful. So I will just pass around IDs and then you pull it from the database every time you need it. That is the worst. Only one service should know how to dematerialize an object from the database and sort of hydrate it into an in-memory system like a PHP system or a C# system. And then they individually should communicate through each other through other means, a message bus, protobuf, Avro, HTTP. HTTP is a good protocol. And if you don't, if that is not good enough, then just internal, secured API endpoints. Even that, API endpoints that are not on the public internet gateway. If that is easy for you to set up, just find something. And as an architect, one of the things that I like to do with these teams is that engineering teams that have never dealt with this kind of system before, I just give them something that they will enjoy copy pasting. I just give them an example of a simple message bus. I would
like to ask you a quick question in between.
Yeah.
Several people responded me with GraphQL as a solution for decoupling. Would you say this is the case? Or is it, let's say, is GraphQL beneficial for loosely coupled architectures or not?
No.
Because your example right now is going into direction.
Yes. So let me put it this way. GraphQL solves a different kind of problem. In a write-heavy system, you're optimizing. Imagine you have CQRS, right? And you're doing it asynchronously. In a write-heavy system, you are optimizing writing in a very granular way, and then when you're reading, I give you everything. So writing is granular, and the reading is just stupid, right? It's just, here's all the data. Or here's all the joins. Here's this entity and all of its joins, right? That is a write optimized system, and that is most CRUD REST APIs. It is being optimized for writing.
But do you couple or decouple your front end?
Let me explain it first, because I will get to that. So this is an example of an API that is designed in such a way that you are coupled to optimizing write granularity, not write performance, write granularity. I have the option to write like this or write like that, or I will put the customer, or I will create an order and it will have like a little customer object anonymously to like squeeze into the customer database as a temporary anonymous user. You do work in e-commerce. This happens all the time. That's one side. Now the other side is completely different. Writing can happen in like an event stream kind of way, but then all of the projections that are necessary, their application as it's connecting, it is so decoupled that the backend system doesn't know in what format the output is needed. So it is decoupled from the format of the output. So the output, the front-end system, the front-end application, the micro front-ends, the federated micro front-ends, some kind of orchestrator on the front-end, Spotify, sorry. Spotify is a orchestrated micro front-end service, right? So that system, the front-end, decides a format of how I want my data to be shown. So that's decoupling, right? So that is a system that has optimized granularity of reads. I know that reading everything is complex. I have a really complex chart, and I usually want to optimize reading vertically along the chart, right? So when I'm commenting on something, I want to see my comments, my user, my settings, and my replies. LinkedIn is very similar to this, right? So it's like a vertical tree. I want the index an ID and then traverse it vertically. Whereas when you go to a forum, you traverse it horizontally. I go to a forum thread and I see all articles or all posts in this thread. And then I go into one, so the user is manually going vertically and the API is serving horizontally, right? Because it's coupled to be written easily. And then you look at it like a library. You're sort of sorting through a database, right? So this is a coupling problem. So GraphQL, you asked, is GraphQL a good solution? So GraphQL is a good solution when you need extremely granular control on how you read, and your backend developers decided to give you CRUD. So your architecture no longer serves the complexity of your front-end application, so then GraphQL is a good solution. But you have to have the need first. You have to have, the Android app is querying slightly differently than the iPhone app. Or the web app the web app on a desktop computer is querying slightly differently than the web app on a mobile phone. Then GraphQL is a good solution. And if the and I'm assuming the reason this got recommended, because GraphQL, is it Apollo? I think Apollo,
yeah,
right?
Apollo
GraphQL has an added feature, which is not the main benefit, but Apollo GraphQL also has this added benefit of it allowing it to represent itself as a federator, which is number one on your list of, what can we do? So GraphQL, even if you don't need GraphQL, the tool Apollo allows itself to represent itself as a federator. Right? So it's the federator that's useful. GraphQL, only if you need it. But there are federators that don't force you to use GraphQL. Now, unfortunately, Apollo doesn't allow you to use non-GraphQL federation, right? So your mileage might vary. I would recommend federating it through a REST API if what you have primarily is a REST API, because state management is much easier on a REST API because you don't have to separate out mutations from reads. That is the main GraphQL problem. It's not a problem. That is the main difference in architecture, right? So it's a different solution to a different problem.
Thank you for answering. This was actually my first question to you in all three. I just needed a question, so I took this one. Yeah. We actually use GraphQL, so I just wanted to hear your opinion about that. So we haven't faced any, let's say, coupling problems with that, but you need to see this, the all the way through. You need to have
verticality that you need to sort of grok.
Yeah, you can't only view the front end. You need to have the API gateway, the caching layer, the message queuing, all this plays together. So if you don't play together very well, GraphQL, in my opinion, could be more a sort of a pain, because on some point it's simply a hidden REST API.
It's a hidden REST,
simply more imperformant. This word doesn't exist in English. Less performant, let's say. And so yes, as always, you need to understand before you execute. But yes, so let's take a look. Do we have some more comments?
I'm refreshing chat because I'm sure my network issues caused the problem that I'm not aware of. So I'm checking unknown unknowns. I'm not sure.
Yes, there are actually some, but not here in the streaming software.
Yeah, maybe the streaming software is coupled to me, and I decoupled accidentally when I had too tightly coupled. Yeah, put them on the stream if you can.
I can't. I see them in LinkedIn, but not here.
Okay. Can you just read them out and then we address it?
Wait a second.
So did we talk? First of all, who's still with us, and do you have any questions? Let's test if the technology works first. Well, we got through the agenda, which I'm really happy about. But there is a matter about microservices, and I think we touched on the components of microservices by talking about GraphQL, talking about federators, talking about gateways, talking about message queues. But we didn't talk about the real pain of microservices. And if we have time, then we'd like to address that. First, I'd like to see. Okay, yeah, Victor is still here. Hello, Victor. That's okay. So we have a live sign. So chat was just silent. Okay, Thomas, thank you. And we lost somebody. They had a little bit of connection issues. So Roshan asked an hour ago. So sorry we didn't get to it. I didn't see your message. How did it endanger the existing projects? What problems were you facing? So they asked us. So tight coupling endangers a project. And I would like to now bring it into microservices, right? So I used to work at a sort of crypto. Balazs, hello. Yes, Balazs made it. Hey, Balazs, it's great to have you. So I used to work in a crypto startup called First Blood, and we went from like a very simple application that was already tightly coupled and becoming a monolith. It had sockets, it had asynchronous communication, it had sticky, web state, it had cookie sessions, JWT tokens, and then it grew. And then we grew the team from 5 to 40 people in like a year, and we went from one small monolith, one Node.js little server that was like hacked together to like 40 and then later 80 microservices. And I was just in the thick of it, and I didn't really know. I constantly had this sort of imposter problem of, okay, do I buy the bullet now and do the enterprise thing? It's like, no, okay, let's stay lean. Okay, do I now buy the bullet and do the enterprise thing? It's like, no, let's stay lean. Because I was always asking, okay, when do I stop everything and create a RabbitMQ cluster, right? Or where do I stop everything and buy a Kafka license on AWS, right? So there was always this problem of, when do we need to hire a Java engineer or plus DevOps person to maintain a Kubernetes with Kafka hub cluster? And I always say, not now. If we need that problem, the team is too large. If we need that solution, the team is too large. Let's make it simpler. And what I did, I found the simplest technologies to make it work now, to make it work in a manner that is still unit testable, unit as in unit of behavior, and as much as possible inside the process. Unit testing refers to this idea that I'm testing a unit of behavior decoupled from external network systems, which means that if you need a Docker container that the test can spin up, that's okay. What's not okay is it communicating with the internet and then pulling down AWS. And now I've never worked in a purely cloud native serverless company, And there it's completely the opposite. They test as much as they can as pure functions, and then they test on production because they need a cluster.
They even develop in the cloud, so they don't even develop on their machines anymore.
Yeah, sometimes they even have an editor open on the cloud provider, and that's how they code. Now, to me, that seems, and I'm biased, but to me that seems heresy. Like that, like having the editor open in the browser, and I'm writing the function as it's running in the cloud ecosystem, and when I hit save, it gets a new ID. And all the cold instances finish, and then the new instance. Like, to me, that's just not. It's just something weird.
We test it from time to time with Jamstacks, so I do it myself for prototyping purposes. So small application, I do that sometimes on the weekend.
Yeah,
and doing some serverless stuff.
Small stuff, amazing.
Yeah, it is. For Jamstacks, it's okay. You have some small applications which needs to have some backend solution things. Of course, you could do that with something like Next.js as well. With with some, but it's interesting to work with the serverless architecture. But as more as I work with that, I want to go back to microservices. To be honest. Of course, let's say you can argue that cloud functions could be microservices. If you would call them nano services, but it's actually no,
because the cloud cluster is a giant server, so it's not a microservice, right? So it's coupled. To...
So microservices are actually a little larger than that, so they are not micro. So maybe this is one of the reasons, because when you need these boundaries, you don't want to stick with too much with the serverless idea, because
So Thomas mentioned this question actually, and Victor now mentioned this, the anti-microservice arguments regarding how it can be overkill for most problems. I think that's when it's overkill. When you have a serverless function and it's hosted in several different regions, it's no longer a microservice because the function might behave differently in different regions. So you need to understand, does my service layer behave the same way in all of the different availability zones or the regions or the types of clusters? Or if I'm doing multi-cloud and I have like an Azure setup and one of my databases on AWS, does it still behave the same? Does it still have the same performance characteristics? Does it have the same SLAs? Does it still have the same, is it the same network? Is it the same security protocol? So there are elements where you might say, oh, the code is only written once, but it has 2 deployment targets. And that's no longer a microservice. That's just you sharing SDK, like the function, the serverless function is like an SDK running on like 2 different microservices.
This is more edge computing than.
That's more edge computing, yeah. So it's really important, what you mean by microservices. Purely cloud native serverless functions, I wouldn't call that microservices.
No, I reverted that already.
Yeah, but at the same time, having like a giant Kubernetes cluster and everything is coupled to the same router. Everything is coupled to the same service discovery. The services between each other are temporally coupled. So there is time-based coupling, right? So it's a connaissance of timing, which means that my service doesn't run if that service is offline. That is also not a microservice. That is a distributed monolith, right? So in order for things to be decoupled, again, loosely coupled, we also need to always take into account the coupling of time, temporal coupling, right? So when you go microservices, one of the biggest mistakes that I see developers do when they go from monolith to microservices is they do not decouple from time. Or they say, I had one server, and this one server didn't have to be decoupled by time because when this class was online, so was this class. So there was no inversion of time between them. Or if they could be offline, then they put it into the database and a cron job picked it up later.
Exactly. This is the reason why we should use message queuing instead of API direct calls.
And you should use message queuing not to pass the data, but to transmit the function call. Right? So what you're abstracting is not the data flow. What you're abstracting is the execution flow of your code. Right? So it's that code that you want to be decoupled from calling another function, not with how the data lives. Decoupling how the data lives, that's event sourcing. It's like, okay, I put it here and there, and then there's an order of events, and then I compute projections from that. That's event sourcing. But what we're talking about is that I am calling a function, and I know the Go community really loves this because they are working in a colorless environment, right? It's because languages like TypeScript, PHP, C Sharp, even Ruby to some extent, Python to some extent, they have this concept of color, where you say, is this function synchronous or asynchronous? Does this function return the thing or a promise for a thing? Does this function execute now or with set timeout 0? Does this function touch the DOM or not? Right? So we constantly have this temporal coupling of, is this a red function or a blue function? If I call it now, will it execute or not? And that's one of the biggest problems of tightly coupled systems, is that developers, even at that level, don't know what to do about that. So the solution is pick a color. And usually the best color is asynchronous, right? So you introduce temporal decoupling or loosely coupling temporally by starting to think about, okay, what can I decouple here? Well, if I log an error after I call a function, that should be coupled together. That should be the same color. But then when I say I need to save a user, and then whenever I save a user, I send an email, that doesn't have to be coupled. Right?
That remembers me with about the introduction of promises in JavaScript back in the days, where people come from the idea of
Blueboard.js, Promise.js.
Yeah, from the synchronous working into the asynchronous working, and people basically didn't make the transition on a large scale. So most people
wanted to go back to synchronous.
Exactly. Still today, you see that. As they introduced await, you see that. Of course, I can understand this when you do write end-to-end testing, where you have a lot of procedural stuff, that might make sense to get a better overview as a human. But as soon as it comes to real business logic, it doesn't make sense to try to synchronize.
Call stacks on exceptions, and the language didn't support that well. Now Go is going for a different solution, even when it is asynchronous by Go routines and channels. The color is the same. The code still reads and functions like it's the same color as the synchronous code. So anything can run anywhere, and you're in a way safe. Now with JavaScript, the problem was that the promises, and I think jQuery was the first with futures. So jQuery had such a bad solution to this that the whole reactive movement said, well, we can just solve this problem by architecture, and we don't need language to solve it for us. Like, we can keep the color the same, then we can just call this reactive architecture, and we can have channels and subscriptions and pipes and pipelines and mapping protocols. So that this was this whole Clojure, Haskell, Lisp-inspired sort of behavioral, functional.
Yeah, and today React actually.
Today React is like this, but React does it. It still has color, right? So React has this. Is the component mount synchronous or asynchronous?
In general, it is, in my opinion. So, for example, you have
problem.
Yeah, but the idea is the same. So there was a good feedback of Marcel Hagemann. He actually took this as an example that you have that in React with your state management, which is actually a messaging queue.
It is. It's a synchronous messaging queue.
Yeah,
over
exactly.
asynchronous protocol, because the DOM is asynchronous.
Exactly. And so you have just a little bit of business logic, basically changing the state, and suddenly everything else is subscribe to that and just react to that. And this is taking away the, let's say, the ridiculous amounts of promise and promise all chains, where basically people fail to create reliable software because of that. Because on some point, when it got too complicated, it was, let's say, that the overall solution quality was dropping significantly, and
callback hell, unclear code, like the code, the happy path wasn't on the left side of the indentation. The happy path was somewhere like in a nested if, when everything goes right and everything, this promise was awaited, and that one, and that one, and that one. And then I showed the form.
And there I would like to give some kudos to the idea of what React and other, similar reactive frameworks do, is we have this topic of loose coupling and decoupling. This is something where we already noticed that especially juniors and intermediate developers do have problems to understand in general.
Mhm.
And frameworks like React help us, or libraries like React help us to focus on the architecture
React
instead
is a
of
library. It's React to DOM. That's the
yeah.
framework.
Yeah,
People get mixed up.
or the ecosystem like
Yeah.
Next.js, which is
Yeah.
called framework as well. But
Yeah.
the idea of what I want to say is, of course, knowing vanilla.js is very important. I
Mhm.
did that for so many years. I understand this. But what we need to understand as well as senior developers who are claiming sometimes that React is bad, it's basically part of the stacks I define for my teams. And the
Yes.
reason being for this is even junior developers can early start to concentrate on programming principles, learning those instead of going into the hell of promises, asynchronous programming, and a lot of business logic, because this is quite hard to learn. And in the end, I'm a business person. This is my thing as a CTO. I need to make sure that business is running, and I'm not a person anymore who says, I believe in a special way of programming. I grew out of that. So no, this is how I did that. So
Mhm.
I don't care too much I care about outcome. And I saw definitely that React speeds up development. Of course, Vue and Angular do the same,
Mhm.
but we prefer React. And it's definitely a better productivity outcome in order to get a good architecture, clean architecture, and loosely coupled solutions. This
But
is what I see in our
what I
environment.
noticed is that the productivity boost came not from React, but by coming from using a library where a lot of behavioral, cosmetic behavior, UI behavior,
Yeah.
is decoupled from the backend that serves it. That was the main productivity boost in my eyes in a lot of teams that I coach and a lot of teams that I work with. Because I used the example of First Blood earlier. We started with Angular there. And one of the biggest changes that we introduced was, well, we needed a completely new UI because some of the systems where you run the game, it was a esports gaming platform. So you run the game and then the browser has like this stupid, standings page. And that's it. And that's okay. And you just mostly the UI is in like a little pop-up in the game itself. But the problem is we then introduced a new feature which says, well, okay, but now teams need to coordinate and have chat and work live together on the website. It has to be extremely low latency because they're making decisions, right? So we went from this idea of, oh, just one person using the website solo to, oh, now it's a tournament and now multiple teams are coordinating with the games. And if they miss the match by like 40 seconds, then they get disqualified. So the in-browser state had to be synchronized live in like a very low latency environment. So we went from not caring about time to having to decouple temporally from not caring about time, so that on one little page in the whole front end, we really cared a lot about time, to the point where if there was a mistake done by the user, we had to know, did they make that mistake, or what did that mistake happen because we didn't show the UI update in time? Did they see it? Did the button appear for them? If yes, and they didn't click it, then we disqualified them. But if they didn't see the button, that was our bad. So it's a technical problem. And so temporal coupling became like a huge thing, and it became a huge component, and it impacted our architecture because we could no longer do that with REST. We could no longer do that with SQL. So I needed something else, and I want to go back and to, just give this idea of microservices some credit, because microservices helped us do this. But it was this underlying infrastructure of, okay, do I need RabbitMQ for this? Like, am I going to be faster with RabbitMQ? Okay, it's like, what kind of instrument am I playing right now? Our code base is growing. It's becoming extremely complex. What is our architecture goal now? I said, okay, I just need a reliable message queue with no durability. And I need low latency rather than being able to replay. If I miss it, it's gone. I need UDP level message queues, not TCP level message queues. I don't want it to block if there's a mistake. So I said, okay, I found this piece of technology called RSMQ. It was before Redis had streams. Now, by the way, Redis has streams, so the message queues are free. You can have free message queues, no problem. And they even save to disk. Like, go nuts with Redis queues. But back then, this was JavaScript running inside the Redis cluster. So you could use Redis sets as as a in-process synchronous, almost synchronous message queues that gave you asynchronous acknowledgement. So it saw, I'm looking at the message queue, I'm taking the message off another system, because a lot of people don't know this, Redis is single-threaded. Redis is, everything happens in order, just like in an SQL database. So everything was extremely reliable, low latency, and then I could scale that out to the degree that I needed. And that was an architectural decision that made me decouple all the little components that we then introduced, like referees and little, viewers and streamers and watchers, not just the players playing, but also people watching it and observing it and spectating it, then replaying it, and then having oversight and referees and payments and verification if did anybody cheat, right? So it was all this added layers of extra complexity that was enabled because we decoupled temporally, and we decoupled by, is this function calling that function? Okay, but I don't want it to know about it. I want to compose that. I want to compose that relationship, not couple it as I'm writing the code, because then if I need to course correct, I need to change the code manually. I can't just change a config and say, okay, I need this fanned out to that other system, so this other system can listen without affecting this one, right? And that's usually what happens. We have following code, services that follow other services. When a user registered, send them this email. That is not an imperative behavior. That is a following behavior. Mm-hmm. When this happens, do that. If you do event modeling, or if you follow the, Eve's Go 11, great name, Go 11. He has this idea that, with event modeling and event sourcing and event-driven architectures, there are like 9 little patterns, and you can express all code with these 9 architectural patterns. It's state change causing state change, it's commands causing state change, it's a timer causing state change, it's a user causing state change, it's a state change prompting the user to do something, and there's timers prompting behavior. That's a time-based trigger that doesn't require the user, right? And that's it. And those combinations, and then aggregates, synchronize these 2 state changes. And these patterns can get everything done. It's just that wherever you're at, if you're synchronously coding and your code is of the color of synchronous, and your code is tightly coupled to all your other code, then you only have access to 2 or 3 out of these 9 patterns, which means that some problems like log in this user and log them out 3 hours later are not available to you. Mm-hmm. Because you don't have access. Your toolkit, your architectural toolkit, denies you access to get to that pattern, right? Because you don't have a message queue. You don't have a message queue where you say, I need a copy of this, and the original I want to be sent with a delay. Or there is a natural delay. I want all incoming messages to be synchronized in a buffer. I want idempotency on the message transition. And if it fails, I want retries. This idea of retries is very ephemeral to front-end engineers and PHP engineers. I don't know why, but they're constantly living in this space that I'm temporarily coupled, and when I call the API, it will definitely be up. And if not, then it's okay that there's an exception. But that's not okay, because that's connaissance of identity. That's connaissance of timing. That's connaissance of execution. I will just throw an exception if the API is not there. No. If it's following behavior, just tell the user, yes, I got it, but the server is not up right now, so wait a few seconds. Right? That's how we should be coding.
And there, just to mention, we were talking about, loose coupling. So there is a development aspect to that as well. So imagine, let's say we've talked a lot about trunk-based development, all this kind of stuff in the last episodes. So when you want to work fluently, continuously on your application, it does make sense to make changes only on the parts you need to make changes.
Yes.
And this we haven't mentioned that in the stream already. And this is very important to understand as well. When, for example, you just said that when everything is coupled temporarily in that moment, so then if your application is down, the entire application is down. Yeah. So if you have deployed something wrong, so take continuous delivery and the idea of removing code reviews, which we were talking about. It's bad if you have a monolithic system where you do something bad, let's say in the messaging system, which is therefore sending out emails and push notifications, and you do something wrong there, then the worst thing which can happen in a microservice architecture is that there are no messages for maybe some minutes or up to an hour or something like that.
Then it can catch up.
But if you break this part of the system, it might break the entire system in a monolith. This is something we should take notice of. So this is definitely a bad business outcome. Then again, we wanted to have everything from strategic level down to operational level. So the more you couple, the worse you can develop. Actually, the less you couple, the easier it is to update specific things, and the more confident you can be to actually push deploy to production without needing 5 reviews of people who are not there at the moment. Because if something breaks, then you only need to check this single part of the application by yourself, and you could roll back if something happened. And this is a big benefit and a big drawback if you don't have it.
So definitely one of the biggest sort of business side advice is you want to encourage your developers to create decoupled systems, which means that sometimes rather than 2 medium-sized features, you get 3 small ones. And don't get scared because of that. If you're creating tickets and Kanban tickets and storyboards and story tickets based on the number of features being added, you might get scared when the developer adds a 3rd one and says, I'm adding a message queue for communication between these 2. This is normal when you're doing Strangler Fig. This is normal when you're doing front-end development. But for some reason, sometimes management gets this sort of, okay, I thought you were doing 2 things. It seems like you're doing 3 things. Don't get scared of that. Encourage that. If you see them decoupling things, encourage that. Don't block it, because if you block it, they will stop doing it, and then everything will be coupled, and then blast radius for like very small, benign, easy changes becomes enormous over time. And this is unavoidable. We are by default going there, even if you're not conscious of it. So you will create this mess, even unintentionally, even with your best intentions, you will still create this mess. So encourage decoupling, encourage introducing federators, encourage. If you don't have the problem of, I think we have too many federators or message queues, then you're not decoupling enough. You should have the problem of having too many and then having to remove a few rather than having too little and you being scared to add a new one. Right? So you want to be on the side of the spectrum of too many, and we sort of need to cut back.
This is my problem, my personal problem I have with modular monolith. So 1 year ago, this was my main topic, discussing the 2 big patterns at the moment back then. And the thing is, for something where you go with, let's say, where you should not try to base your outcome on discipline. Because discipline is a temporary thing. It can change over time. So let's assume you have a team of 5 developers. They are, they know each other very well. You start with, you have a high discipline, your high maturity, high sense of ownership. And then after 1 year, half of the team is gone. New people come in, you have fluctuation, new mindsets, different ideas, and suddenly everything changes and things start to couple without noticing it, And yes, a pattern, let's say a pattern is theoretically in a modular monolith as good as a microservice pattern when it's still a, let's say, closed application.
Eve's Go 11, those 9 patterns are.
But it's not practically the case. It is not over time. And this is my problem. And one thing I want to add, I every time I edit this, once you get into the modular monolith, you won't get into the microservice architecture, because this is a second migration you do. And if you already have problems to go into the first one, you will have problems to explain to the business that you want to do a migration again. So just go all the way. This is my personal opinion, and this is how it worked for me for many years now, without any problems, without long-term problems. And microservices are not that complicated as people describe it. It's like, if you go for microservices, you are suddenly in hell. You aren't. So actually, we're working with that with all kinds of developers. There, I don't see, of course you need to learn some new stuff, but you need to learn it anyway to apply design principles. So this is my take on that. You as a developer need to learn, continuous learning, become a learner. Change your mindset frequently to a positive and beneficial outcome. And, when you do that, then you understand microservices and the idea behind it, because the idea behind microservices is not to have microservices, is to have a better and clean architecture
Yes.
which is resilient. This is a term which is used in the cloud very often, and in the business, on the business side. You need to have and reach the goal of having a resilient application, resilient to problems. So as I said, discipline, you can't rely on something which change over time. You need to have some form of mitigation
The
which
architecture
evens
is
the
the
problems
constant.
out.
Yeah, the
Exactly.
architecture is the constant, not the engineering culture. The culture
Yeah.
might abruptly change. So you want to make sure that the culture defines architecture, that you're making it easier to add your features. If it's
Right.
hard to add features into your system, you probably have an architecture coupling problem or a process coupling problem. Maybe two people need to synchronize too often or not enough. We do it asynchronously badly. So they're definitely federation, temporal decoupling, and learn these patterns. Learn the few simple patterns, not with enterprise grade technologies, just like technologies that serve your needs. It's PHP. This can be as simple as in-memory communication, APC if you need it,
A,
Rabbit,
a little tip.
Redis.
A little tip. We got a comment. I don't know, half an hour ago. How to start?
Mhm.
What are the first steps? And just for people who are very new to this topic, or don't know how to start, if you have an old legacy system, big ball of mud, just start to create a new service somewhere else. For example, if you have it on your data center, go to some solution like
Yeah,
DigitalOcean,
go to
create
your
an app platform. It's very easy to do. You don't
yeah.
need to know Kubernetes at all. You just need to know Docker, for example. Push that, have that running, and then federate it just via you don't need to have a federator to starting. You can do the first test just with your front end. Just go for another target location,
Mhm.
fetch the data from there, and try to play around with that. Get into the flow and start to understand this. Make experiments, make prototypes. Every team should have some budget for experiments.
Yes.
To do those things, and then you get into motion again. We talked about that, and you get into experimenting and understanding those things. And as soon as you understand those things, the barrier and the hurdle to actually get into, let's say, a real continuous delivery
Scale it.
mode with
Yeah.
Microsoft is easy then, because you need to understand first, and then suddenly you're not hesitant anymore. And this is what I can give you with just start with, and I would be interested and curious, for the people who are still there. Would anyone be interested in how actually, let's say, is there someone who needs help from getting from a monolith to start with that one? If yes, we could, or I could do some content about this, how we actually manage this with very,
we can
very
even,
simple things,
if it's necessary, we can even host workshops for them directly with their company, or just have like a public group, maybe a public open table discussion on this topic as a continuation. I will be posting on this on my newsletter recently. I was super busy this week, so I'm sorry I didn't get to post that one or two posts this week. Sorry, audience, for letting you down. But I will post a lot about federation and temporal decoupling. Temporal decoupling is a concept that is very important to me. So I would definitely encourage everybody to learn it. Follow us on our newsletters if you want to stay in touch, and do let us know when it's if you want to be in the loop and want to actually have hands-on help. Adrian showed me all his magic that he's doing with DigitalOcean droplets and everything that he can do with app specs over there. It's really easy to set up. It's really easy to set up to the point that you don't need to learn all this complex stuff. If you have like a little Docker image somewhere, or you just copy a Docker image somewhere and your service can run inside it, then you already have everything you need. Because everything else can just be adjacent to that. A MySQL database, a Redis, a simple message queue. There are even simple message queues which aren't production grade, enterprise grade.
There's the last question, so maybe we should go with that and wrap up then.
Yeah, because Angel is also joining the book club, and I'm probably late for that meeting already. Okay. So when is it worth it for a company doing microservices and not a well-designed monolith?
This is definitely a business question, right? Mm-hmm. I tell this now as a CTO, as a businessman, as an entrepreneur with 15 years of experience. 10 years at minimum with primarily monolithic experience, and now 5 years of microservices.
Yeah.
6 years actually, and with a lot of companies we work with in fellowships and all this kind of stuff. I would never ever go again with a monolith if not anyone forces me to do that. Yeah. This is my standpoint. Business is hurt by monolith in long term.
Absolutely.
Period.
Yeah, it's good to learn how to break up a monolith. It's an important skill. Don't be scared of a big ball of mud monolith. Learn how to break it up. If it's scary, if it's painful, learn what to do about it. That will solve your career. You will never be afraid of it again. That is more important than avoiding building one. Knowing how to break apart a monolith is the best skill you can have as an architect, engineer, business person on any level, tactical, strategic, business. It solves all problems. Just knowing how to decouple yourself from a mess.
Your solution will grow. It will grow.
Your solution
it will outgrow the monolith very soon.
If it's successful, if your business is successful, the code will grow and will become a mess.
Yeah.
So this is the equivalent of learning how to industrially keep a kitchen clean. This is that skill, and this will set you apart from really bad chefs and kitchens. I just had to throw in a restaurant analogy. So Kaloyan, if you're still watching, this one's for you. I do need to go now. Adrian, thank you so much. This is a great topic, great conversation. Really enjoyed it. Follow us for those who are still here. We'll have a recap on Tuesday, audience participation, and I'm gonna send you off with some elevator music. Adrian, thank you.
Goodbye, everyone. Goodbye, Dennis. Bye-bye.
Oh.